So me and my team work on trying to get the best out of the sea for people. We're trying to understand things about where animals live in the sea, what resources they need in order to sort of survive and thrive and contribute to the next generation. And we use that information to try and make policy for how humans use the sea better, so that we can get the maximum benefit from the sea without destroying biodiversity in the ocean, destroying the resources that we depend on. I mean, the biggest thing is overuse of the sea by fishing and destructive ways of fishing. We've done a lot to destroy the habitat that marine animals use, the nursery areas where young fish need to live while they're getting big enough to sort of contribute to the next generation. We've done a lot of just over-harvesting of animals, just taking too much. Then we've got the sort of emerging stuff. We're doing a project on microplastic pollution at the moment. There's a lot of concern about microplastic, but we really have no idea what the ecological implications really are, and that's what we're trying to work on at the moment. So there's some quite direct examples of the impacts of our research that we can point to. The big ones were on deep sea fishing, for instance. Deep sea fishing was going on to depths of about 1,500, 1,600 meters, and they got cut to 800 meters, taking dozens of species of fish out of the range of fishing basically forever in the Atlantic. So these are species that would naturally live to over 100 years, but also dozens of species that were just being caught as accidental bycatch. You know, they were just there in the wrong place at the wrong time. That made a big difference and contributed to the EU changing the law on deep sea fishing, protecting just a colossal area of the sea. So we're very proud of that. At a more local scale, we have a terrible problem on the west coast of Scotland with the cod fishery. We investigated whether or not the existing measures to protect them while they were spawning have been successful, and found that they hadn't been. So those measures have now been strengthened. It's very, very controversial. You know, the politicians got an enormous amount of heat for that. But, you know, it is supported by the science, right? So we do have these occasions when things that we do can clearly matter. The next frontier in terms of the natural science side of things is to understand the impact of the whole underwater landscape or seascape. So understanding not just which types of seabed animals particularly benefit from, but how they use the whole mixture of different seabed types across areas of dozens of kilometers, that sort of thing. So we progressively started to realize that the boundaries between different types of seabed are important. So we've started doing things like making whole maps of whole areas of the seabed, and then we can relate where animals are, not just whether they're in algae or on sand or mud or rocks, but also how that relates to how close they are to other sorts of seabed. So this is a whole thing that we've been working on for the last 10 years or so, that we've progressively realized that the mixture of different seabed types is as important as the individual types of seabed. So that's the next big thing that we're working on at the moment. It's a great place to work. I have outstanding colleagues. It can be a very kind of pressurized environment in academia, and it makes an enormous difference if you know that your colleagues have got your back and, you know, will support you, but also that will have great ideas that they're happy to talk to you about. That sort of supportive attitude really does go like right the way from top to bottom in the organization.